In this problem, we're asked to figure out how high a kite is flying above ground. So let's start with drawing a picture. So we're told that a person is flying a kite and is holding the string 4 feet above ground. So there's our little stick figure person. He's holding a kite, and the distance from the end of the kite to the ground is 4 feet. We're also told that the angle the string makes with the horizontal is 60 degrees. So this angle here is 60 degrees. And we're asked to approximate the height or find the height of the kite above level ground if 500 feet of string is let out. So that means that this distance of string is 500. So we can see a triangle then with our carefully drawn picture formed by knowing that the hypotenuse of this triangle is 500. The angle of this side is 60. This is a right angle. And what we're trying to find is the height of the kite relative to where the person's holding the kite. So because we know the side opposite to this angle and the hypotenuse, that would suggest we should use the sine of 60 degrees, because that's equal to the opposite side divided by the hypotenuse. Solving for h, h equals 500 times the sine of 60 degrees. Now sine of 60 degrees is one of those special values that we can find directly, because we know that if we have a 60 degree triangle like this, the opposite side, the sine or the y-axis, is going to be the longer side, which in this case would be radical 3 over 2. So this would be 500 times radical 3 over 2. Again, think of this as being the sides of a unit circle. So if we had 60 degrees here, the coordinates would be 1/2 radical 3 over 2, and so there's the sine of 60 degrees. So there's the height of the kite relative to where the person's holding it, but then if we go back and look at the problem, it's asking us to find the height of the kite above level ground, which means we need to include the additional 4 feet of distance. So the height is actually equal to 4 plus 500 radical 3 over 2, or 4 plus 250 times radical 3 feet.